Hey everyone, I'm Dr. Michelle Thaler and I'm thrilled you're here. Welcome to our deep dive into the fascinating and critical story of asteroid impacts and planetary defense. From ancient events to modern-day strategies, let's explore humanity's journey to understand and protect our planet. You know, when we look up at the night sky, we often feel a sense of awe and wonder. The stars have captivated humans for millennia, but the vastness of space also holds potential dangers, and among them are asteroids, remnants from the early solar system zipping around our cosmic neighborhood. For billions of years, Earth has been a target in this cosmic shooting gallery. While most asteroids are harmless, some have left their mark on our planet, shaping the course of life itself. So, buckle up as we journey through time and space to uncover the science, the threats, and the incredible ways we're working to defend our pale blue dot. Let's rewind the clock way back. 66 million years ago, an asteroid about 6 miles wide slammed into Earth near the Yucatan Peninsula in Mexico. The impact unleashed unimaginable energy, equivalent to billions of atomic bombs. The result? The Chicxulub Crater, a massive scar on our planet stretching over 100 miles wide. This catastrophic event wiped out the dinosaurs along with nearly 3/4 of all plant and animal species on Earth. But the Chicxulub impact is just one dramatic example. In 1908, a much smaller asteroid, perhaps only about 100 feet across, exploded over Tunguska, Siberia. The airburst flattened trees over an area of 800 square miles, with the energy release estimated to be about 1,000 times greater than the atomic bomb dropped on Hiroshima. And then we have Meteor Crater in Arizona, a stunning reminder of an impact that occurred around 50,000 years ago. This crater, nearly a mile wide, was formed by an iron-nickel asteroid estimated to be about 150 feet in diameter. These ancient impact events, etched into our planet's surface, serve as stark reminders of the power these celestial objects possess. So, what exactly are these celestial wanderers that pose a potential threat to our planet? Asteroids are rocky, airless remnants left over from the early formation of our solar system about 4.6 billion years ago. Most of them reside in the asteroid belt, a vast, donut-shaped region located between the orbits of Mars and Jupiter. Now you might be wondering, what's the difference between an asteroid, a meteoroid, and a meteorite? Well, it's all about location, location, location. An asteroid is a large, rocky body in space. When an asteroid or a piece of it enters Earth's atmosphere, it becomes a meteoroid. And if that meteoroid survives its fiery plunge through the atmosphere and lands on Earth, it graduates to meteorite status. Now asteroids often get lumped together with comets, but they're not quite the same. While both are leftovers from the solar system's formation, comets are icy bodies, often dubbed dirty snowballs. As they approach the sun, the ice vaporizes, creating that spectacular tail we often associate with comets. Asteroids, on the other hand, are mostly composed of rock and metal, making them a bit less flashy but no less important in the grand scheme of things. For a long time, the threat of asteroid impacts seemed like something out of science fiction, but in recent decades we've had some dramatic wake-up calls. On February 15, 2013, a meteor, about 66 feet in diameter, exploded over Chelyabinsk, Russia. The shockwave from the airburst injured over 1,600 people, mostly from shattered glass, and caused millions of dollars in damage. The Chelyabinsk event was a stark reminder that even relatively small asteroids can have significant consequences. The Chelyabinsk meteor wasn't even on our radar, highlighting a critical challenge: early detection. But back in the 1990s, there was a growing awareness of the potential threat posed by near-Earth objects, or NEOs. Scientists began to realize that there were many more asteroids lurking in our cosmic neighborhood than previously thought. This realization led to the establishment of NASA's Near-Earth Object Program in 1998. The program's mission is to coordinate NASA's efforts to detect, track, and characterize potentially hazardous asteroids and comets that could pose a threat to Earth. The program funds telescopes and surveys to scan the skies, looking for those telltale points of light that could spell trouble. The Chelyabinsk event and the growing awareness of the NEO threat spurred a new era of planetary defense. In 2016, NASA established the Planetary Defense Coordination Office, or PDCO, to manage our nation's efforts to protect Earth from asteroid impacts. The PDCO acts as a central hub, coordinating with other government agencies, international partners, and the scientific community to develop strategies and technologies for planetary defense. One of the most exciting developments in recent years has been the Double Asteroid Redirection Test, or DART mission. Launched in November 2021, DART was the first ever mission designed to test a method of asteroid deflection. The mission targeted Dimorphos, a small moonlet orbiting the larger asteroid Didymos. In September 2022, DART successfully slammed into Dimorphos, altering its orbital period and demonstrating the potential of kinetic impactors for deflecting asteroids. When it comes to planetary defense, practice makes perfect, even if it's just a simulation. NASA, along with international partners, regularly conducts planetary defense exercises to test our readiness for a potential asteroid threat. These exercises bring together scientists, engineers, policymakers, and emergency response personnel to work through hypothetical impact scenarios. One such exercise, conducted in 2019, simulated the discovery of a fictional asteroid on a collision course with Earth. Over the course of several days, participants worked through the challenges of tracking the asteroid, assessing its impact potential, and developing deflection strategies. These simulations are crucial for identifying gaps in our knowledge, refining communication protocols, and ensuring a coordinated response in the event of a real threat. The importance of global cooperation in planetary defense cannot be overstated. Asteroid impacts are a global threat, and no single nation has all the resources or expertise to address it alone. International collaboration is essential for sharing information, coordinating observations, and developing and deploying deflection missions. So how do we actually defend our planet from asteroid threats? Well, scientists and engineers are developing a range of innovative techniques, each with its own strengths and limitations. One promising approach is the kinetic impactor, like NASA's DART mission. This technique involves slamming a spacecraft into an asteroid at high speed to slightly alter its trajectory. Another intriguing concept is the gravity tractor. This involves positioning a spacecraft near an asteroid and using the spacecraft's gravity to slowly tug the asteroid off course over time. While this method requires more time, it offers greater precision for deflecting larger asteroids. For more immediate threats, nuclear deflection might be an option. This controversial technique involves detonating a nuclear explosive near an asteroid to vaporize part of its surface, creating a jet of material that propels the asteroid away from Earth. However, this method carries significant risks, and would only be considered as a last resort. And then there's the slow push-pull method. This technique involves using a combination of solar sails and ion engines to gradually change an asteroid's trajectory over an extended period. While this approach requires significant lead time, it offers a more controlled and predictable deflection method. While we've made significant strides in planetary defense, challenges and gaps remain. One of the biggest hurdles is early detection. Many potentially hazardous asteroids remain undetected, lurking in the darkness of space. We need more powerful telescopes and improved search algorithms to find these threats with sufficient lead time to mount an effective defense. Funding is another ongoing challenge. Planetary defense often competes with other priorities for limited resources. Securing sustained funding for asteroid detection, tracking, and deflection technologies is crucial for ensuring our long-term safety. International collaboration, while essential, also presents challenges. Differences in national priorities, legal frameworks, and technical capabilities can hinder cooperation. Building trust and establishing clear lines of communication among nations is essential for an effective global response. And finally, we must acknowledge the limitations of our current deflection capabilities. Most of the techniques we've discussed are still in the early stages of development and have yet to be tested on a large scale. Further research and development are needed to refine these techniques and develop new ones that can effectively address a wider range of asteroid threats. Asteroids pose a real and ongoing threat to Earth. However, advancements in science and technology, along with global cooperation, provide hope. By developing detection systems, testing deflection techniques, and uniting worldwide efforts, humanity is taking critical steps towards safeguarding the planet from cosmic threats. We've journeyed through time and space, exploring the impact of asteroids on our planet and the incredible ways we're working to protect ourselves. From the scars of ancient impacts to the cutting-edge technology of planetary defense, one thing is clear: we are not passive passengers on this pale blue dot. We are active guardians, shaping our cosmic destiny. Thank you for watching, and don't forget to like, share, and subscribe for more insightful content.